Okay guys, I have had some questions about how weight shift works on a Stinger rig. So I've done this beautiful first-rate drawing of a Stinger rig. Hope you can tell what it is. Alright, so I'm going to try to explain it. So, for example, steers, drives, trailer axle, tires. When you're dealing with a Stinger, you have to understand the physics of leverage and cantilever leverage. So there's two kinds of Stingers out there. One that has no head rack out here, it only has a 2-car head rack here. Stinger trailers are all basically the same from our physics discussion standpoint. Some of them will be 6 cars, some will be 7. That doesn't really change anything other than where your vehicles are placed on the trailer. Okay, so there's several things you can do when you understand the physics of leverage and cantilever leverage and weight transfer to help adjust the weight on your drives or your trailer axles or whatever the concern is. So let's say that you have overweight trailer axles, you have your drives that are nearly maxed out, and for the sake of this discussion, for starters, let's just say that this is the end of your rack right here. You have no rack out over here over the hood of the truck. So if you're already maxed out here and you're overweight here, there's only one thing you can do: offload a vehicle. That is the only way to get your truck where it's legal. Changing places, you're going to shift that overweight back and forth. You might put overweight here and get it legal here, or you might even the weight out to where you're less overweight per axle set depending on what state you're going through, but there is nothing you can do to get that truck to where it's totally legal. Okay, now here's where the question arises. When you add this third rack to your head rack assembly on your Stinger rig, this can be a big asset. It can actually help remove weight from your drives. But here's where a lot of people don't understand the physics of it. So let's say that you are already basically maxed out. Let's say you're at 34,000 on your drives, and you're in a state that only allows 34,000. Adding a vehicle here is not going to help, because what you have to do is you got to look at this line right here. And as you can see, the majority of this vehicle is back here. Everything from this line forward is going to add steer weight, not drive axle weight. Everything from here back is going to split its weight to a degree between the steer and the drives. Now, it may put more of the weight on the drives than it does the steers, but it is still going to add weight here. The only way that you can take this vehicle and shift it to get weight off of the drives is if you can run it far enough forward that the majority of the weight then cantilevers out beyond this balance point to where the weight that's out here is wanting to tip down and lift the back tires. Okay, but if you're already maxed out here, then adding this vehicle, unless you can get all of that vehicle's weight to where it's beyond this center point, or at least to the point where the majority of the weight is, let's just picture this as a scales right here, okay? And this point right here is your pivot point, like the old-fashioned weight and measure system. Okay, so you look at that vehicle, where it's sitting in, which way is it going to tilt? Like that. Unless the engine is heavy enough that it outweighs the back of the vehicle. But then you have to have this vehicle far enough forward to where it outweighs it enough to lift enough weight off of this to make up the difference to get these tires, these axles, to where they're no longer illegal. So basically there's only 3 ways, short of removing a vehicle or changing positions, that you can get weight off of your drive axles on a Stinger. Okay, so one of them is adding enough weight forward of this pivot point that it basically lifts, it leverages weight up. Okay, shifting these 2 vehicles forward will obviously help balance that weight out some. Or if you have a sliding fifth wheel, the farther forward you slide this, the less weight there is here. The reason for that is, again, you look at the point of where your kingpin is, okay? Consider this line right here to be your balance point, all right? So you take this trailer and you slide it forward. The closer you get to these axles, the less weight. What it does is all of this weight is still gonna be sitting here, but it allows some of the weight to shift to the front axles because it's not cantilevered beyond this pivot point right here. The farther back you go, it's like if this is the pivot point, the farther, and this pin is totally balanced, you set a penny right here on the center and it's going to stay that way. But as soon as you slide the penny back here, it's going to want to start tilting. The farther you go out, just like on a teeter-totter, you can put two people of two different weights as long as the heavier person is closer to the pivot point and the lighter weight person is farther out. Physics, the physics of balance. So with this kingpin, the farther forward you get it, the more it allows the weight to balance between the steers and this. You still have the same amount of weight on the truck overall, but it will allow it to balance out. So if you have weight available, like say you have just a 2-car head rack, you're gonna run light on your steers all the time. It's a really awesome truck because it has a full-size sleeper, but it has the challenge of not having this vehicle to help shift weight beyond this pivot point to lift weight off this. But again, if you're already maxed out on your weight here, you're just adding more weight to the truck. You're not actually going to be taking weight off unless this vehicle goes so far forward that it cantilevers that weight, that it overbalances the teeter-totter, if you will, to lift weight off of these tires. The other thing you can do to lift weight off of these drives, if you don't have a weight problem with, let's just say you happen, which is really rare, to get overweight on your drives, the farther back you can put the weight, again, remember, right between these two axles is the pivot point, just like on a teeter-totter. You want to take all this vehicle weight and you want to slide it backwards so that it begins lifting the weight off of the drive axles because it's putting it back here. But if you're already overweight here and you're already maxed out here, adding a vehicle here is only going to make the problem worse. Again, the only way this helps is if you are not maxed out on your drives and the weight of this portion of the vehicle that you're adding here can be shifted far enough forwards to make enough cantilever difference out here that the steer axles is what's carrying the weight of this vehicle to the point that it begins lifting this weight. It means you can't just balance the car here, you actually have to take it out so that the fat guy on the teeter-totter is way back here, is way out on this end, and the skinny guy is back here so that it starts lifting. So, quick recap. Enough weight forward of this pivot point line that it lifts here, shift these vehicles forward, shift these vehicles backwards, or the fourth one would be, if you have a sliding fifth wheel, running this weight forward. But again, if you're already maxed out here, it's not going to help you. You've got to have room to shift from these wheels here to this one. Hope all that makes sense. Feel free to holler if you have any more questions.